Okay, we're there finally. Good afternoon, everybody. Welcome back here at the EIMA Digital Terrace at EIMA International 2024. Still talking about new technologies and still talking about robotics, AI, perception, which looks to be the most attractive topics during this event and this trade show. Today we're gonna cover a few, well, the title is in Italian, sorry for that, it's not be translated, but we're gonna holding the presentation in English, so don't worry. So I'm very glad to see a lot of international people here in the audience. We're gonna cover different aspects of the technology in robotics for agriculture, from perception system, software development, and how to validate functionalities in agricultural machineries. Talking about those topics with our guest, Professor Matteo Matteucci, Politecnico di Milano, Carmelo Di Franco, Eitronic, Marco Bertogna, Università di Modena e Reggio Emilia, Professor at the Università di Modena e Reggio Emilia and founder of Hypert, and Raffaele Giaffreda from Fondazione Bruno Kessler in Trento. I'd like to give you my welcome to Professor Matteucci, speaking about how the perception is used for perceiving the situation in the fields, in the crops, and maybe how this information could be used. Thank you, Matteo.
Thank you, Alessio, for inviting me. Thank you, everyone, for coming. I will try to spend like 10 minutes or 15 or until they stop me, talking about some experiences we did on the field working with robots. Just a short introduction about me. I'm a full professor at Politecnico di Milano, Department of Electronics, Information and Bioengineering, and my research interests are in robotic and perception. And when I say perception, I mean the basic element of getting data from sensors and making sense out of these data so that the robot can take a decision and then act on the field. And when we talk about the field, you see some of the applications regarding agriculture here in these videos. And I would like to talk about this, but I would like to start from where everything started. A few years ago, I took part of this project. It was a really preliminary study on how a robot could be deployed on a field and perform some activities on the field. It was one of the first examples of on-field manipulation. The task was to use that robotic arm to place pheromone dispenser against pests on vineyard. You see here some of the field experiment. It was an international project together with Eurecat, which is a research center in Spain, you see here, and we were hosted by them in this vineyard in the northern part of Spain. And here you see that the robot has to find the right place to place the pheromone dispenser, and to do this uses a pheromone detection, a vineyard reconstruction algorithm. You will see in a minute that through this arm and the laser sensors that has on the arm, the robot is able to reconstruct the vineyard and to detect which is the right spot to put the pheromone dispenser. Now you see here, it was like 7 years ago, so not too many 3D leaders, so to have a full 3D reconstruction, we were doing like a scan with a single leader. And here you see the plant, and there was the right place to place the dispenser and the wrong place to place the dispenser, and then there was the arm getting the pheromone and placing on the plant. So the idea was to have a sort of multifunctional robot to go on the field and support the activities of the farmer that had just to prepare the robot, send the robot on the field, and whenever the robot was traveling on the field, it was able to perform some simple task, but it was also able to gather data. Indeed, one of the key aspects of having robots or autonomous devices with sensors on the field is that they can gather data and provide information to the farmer in the sense that then it can take data-based decisions and not just decision based on historical practices, and that they don't take into account the current situation of the field. I mean, this is not my idea. I mean, this is something that has been suggested by FAO. FAO is a food organization by United States, and the idea of agriculture 4.0 of FAO is to have sensors on the field and platforms that collect data that through AI are used to make data-informed decision and then to be actuated. As you can guess from the title of my talk, I'm mostly interested in the data part and the AI part. And when you say data, you can have data at different frequencies and at different resolutions. So you can have satellite data, you can have IoT data, you can have data collected by aerial drones and ground drones. And based on my past experience and the project that I've been doing in my research, the ground vehicle are those that I have used the most. And when I say ground vehicle, I also mean agricultural machine. This is a project we did a couple of years ago with Gregoire. It's a European project on deploying AI algorithm on the edge. When we say on the edge, is on the platform, not on the cloud. The edge is the opposite of the cloud. And the idea was to use sensors that were already on board of the truck, and they were used for autonomous driving or for line following. Also to decide when and how much to spray in order to optimize the treatment. And the idea is that, here you see a running example of this. The idea is that if there is no vegetation or if the volume of the vegetation is poor or very low, there's simply no reason to waste product or just dispose the product in the environment. It's just polluting and it's not giving you any benefit out of that. This is experimenting on the field with some 3D vision system. And again, perception is used as the base for decisions. This is another work that we have been doing with my colleagues of Università Cattolica in Piacenza, and the idea is to be able to estimate the yield of a field by using vision. In this case, it's pure vision, and we use AI algorithm in this case to detect the boundaries, also those that are in an unexpected and unpredictable position, and then to count them. So we are able to track them and to estimate the volume of the grape in the ground. Now, counting the bunches is not the volume that you would predict. I mean, these are, but they are highly related. So what we did was to also build a very simple model that was able to translate the number of bunches on the grapes into the volume of, let's say, possibly wine or yield in the future. Clearly, it's not perfect. You have noise, you have errors, but you have errors also with human. I mean, if you go on the field and you count manually the number of bunches, usually humans have 10 to 15% error, and this algorithm has from 5 to 11% error. So yes, there is an error. Algorithm for perception are not perfect, but still they are in line with human performance, so they can eventually replace human or support human in taking their own decision. More recently, we have been moved to what we call 4D mapping. What do I mean by 4D mapping? Well, you know what does it mean 3D. I mean, you have 3 dimensions, X, Y, Z. So you have the volume of the vineyard. But the vineyard or any culture like an orchard, they evolve through time. So if you take the map of the vineyard today, is one single frame in a video, in a movie, because the vineyard evolved. I mean, you have a season, you have some examples are, I mean, different stage of the growth of the plant. So the idea is to have autonomous robot. Here you see a couple of the robots that we have developed in our research that can move through a vineyard, build a 3D model of the vineyard, and monitor this 3D model through the month in order to predict or to have a prediction. So here you see some running examples. So through our algorithms, we are able to detect from the point cloud collected by the leader which are the plants, where are the plants, and once we have counted and monitored each single plant, we can build a 3D map that we can use later on to reason about the yield, to understand whether in the last 2 months one of these plants is not behaving as expected, whether one of these plants might have incurred in some disease and you would like to intervene. Now, this is a 3D plus time, that's the 4D, but you have also the visual appearance of a plant. So we are also developing neural methods to reconstruct also the appearance of the plant. Because when you detect something that is not working as you expect, what you would like to do is to have a picture of this plant, provide an agronomist the picture of this plant and take a decision about the appearance of the plant. And another work that we have been doing, so far I've been focused on vineyard, orchard, but another work that we have done, this is in collaboration with the Università degli Studi di Milano and INRAE in France and LNE in Paris, was a contest on weed detection. So you see many robots here being able to detect the weeds and using AI to understand what is a plant, in this picture the white part, or what is a weed, in this picture the red part, and so you can act accordingly to remove the weed and leave the plants. There are different techniques. Some of the robots that you see around, they just detect the plant and kill whatever remains. I mean, reasonable. Some other, they just focus on a single weed, so like with spot spraying or laser weeding. This is the idea. We also collected the data set for comparing different algorithms in different conditions and with different cameras. You see RGB cameras on the left and near infrared cameras on the right, and in normal conditions, but also in challenging conditions. I mean, because your robot should work 24 hours, and you might have like shades and in the morning and in the evening, and your AI should be able to work also in this condition. Just last two examples that I would like to say about these ideas of using perception and artificial intelligence to improve agriculture or to develop new applications. This is an example in fruit harvesting. The robot passes in front of, well, clearly this is not a real orchard, it's a lab orchard, but next step will be to go on a real orchard, but it is able to build a map of the yield and then decide what should be the apple to grasp. In this case, we used a soft gripper, not to damage the skin of the apple. So, I mean, this is a special one. You see the blue fingers that can be open and closed, and you can grasp without damaging the... Well, you're not going to damage this one, because they are fake apples, but in general, in the future, you will have not. And this is the last examples that I would like to talk about, is full autonomous robot. This has been developed together with the Università degli Studi di Milano, the agronomic science department. And you see here on the left the real robot. What is doing the real robot on the left is doing autonomous navigation in a field. And on the right, you see a simulation of what would be the behavior. And again, we have this spraying task where through sensors you are able to understand how much and where and when you should apply the treatment. And you see here you are able to precisely address the presence or absence of vegetation. So with this, I would like to close. There will be an opportunity to talk later on more about these, and I will thank everyone for listening.
Thank you, Matteo. We'll be discussing that a little bit later with the question session. Of course, there's a lot of noise in the data you're gathering in the field. There's a lot of noise here, so I ask you to speak loud or louder than the people below. I invite then Carmelo Di Franco, Senior Software Engineer and iTron. We're now focusing on a part of this robotic system, which is the software.
Thank you very much. Good afternoon, everybody. I'm Carmelo Di Franco, and I am a Senior Software Engineer at iTronic. It's a company that develops software for robotic applications. So we focus on software, And today's talk is actually on how we manage the software development lifecycle, starting from the initial idea to the final product. So, when developing software for agriculture, and not only and beyond, of course the biggest challenges arise when you need to do specific algorithms. We show a wonderful presentation by Professor Matteucci about many interesting perception algorithms, but we realize that these are not only the issue that we face when we want to deploy a product, because one of our challenges that we have start from the beginning, when we start interacting with the client, the manufacturer that wants to create an idea and goes to the product. And we picked three main challenges that we think are fundamental. The first is understanding requirements. So it's really difficult, and it's important to understand how to communicate efficiently with a manufacturer, with a vehicle manufacturer. Then there is the most important part, of course, that is writing high quality code, doing a lot of algorithms, but always keeping in mind that there are many cross-platform issues. The hardware can change over time. There are many constraints that arise when dealing with the final product. And finally, once the product is on the market, the other challenges arise. How to manage software updates, how to update some features in terms of hardware and on software, and also how to deal with regulatory changes. So let's talk about understanding the requirements. We realize that often there is no clear understanding of on how an idea can be put in practice to a final vehicle, mainly in terms of time, resources, and hardware cost. And it happens that there is a lack of communication between the software team and the manufacturer, and if there is this lack of communication, this can lead to really important issues after some years of development, because it's going to happen that after 1-2 years, the final idea is different from what was in mind of the client. So in order to achieve this, we perform iterative and incremental iterations with the client. So we involve the client directly in the decision process, starting from the initial idea. I show this image here that show the interactive incremental and interactive incremental differences. That's because the final product is always different from the initial idea. It happens that the clients arrive, he has some ideas in mind, but then you're gonna change the sensor, the cameras and everything. And in order to keep things going from the software point of view, it's fundamental to have this good understanding with the clients. And we value a lot what we call the minimum viable product. That means that we are not going to build a product and then in 2 years we go to the client and say, okay, this is your product, because it can happen that during these 2 years things change. Then we go and we have some feedback that is not exactly what the client was having in mind. So what we do is to build the incremental steps of the product. So we always provide a subset of features that can be deployed to the client, can be understood by the client, by the final user, and in this way we can iterate with this iterative process, and we are able to correct the changes over time. It happens once, for example, that we were starting with, 2 LiDARs and 1 camera. We end up using only 2 cameras. And by doing this cooperation with the clients at monthly base, weekly base, we are able to really cut the time. And then there is the most probably critical things. So writing good quality code. I'm a software developer, so of course it's hard to write code that works on different platforms, has a different level of hardware performance. So for example, different CPU, different RAM, the sensor. It happens often that you don't have an idea about what will be the final sensor, the final attachment since the last few months of your production. So you have to write some code that is agnostic enough in order to be able to test everything and be able to do changes when needs. And the system must be easy to use. Of course, we can write sophisticated algorithms, incredible applications, but if the system is not easy to use by an end user, by someone that is actually using the agricultural tractor, it's going to be difficult. It's really difficult to be sold by the client. So these are many challenges, and what we do to solve that. This is probably what every software company does or should do. So we follow many best practice, the C4 model, the design patterns, the solid principles, that what they say is actually build something that is modular enough that you can change the components in an easy way. So always provide a single responsibility to each of your components, and in this way, whenever happens that you have to modify that because of regulation, because of a completely new change in the customer ideas or so, you are able to react. And finally, we go to the product life cycle. So we have our product, we go to the market, and then it starts with software updates. It happens that we receive feedback by the client, by the users. So maybe we start doing some changes, but these changes must be retro-compatible. But also it can happen that some of the sensors goes out of production or is not longer available. So we have to be prepared to change and update the software in order that the hardware is still consistent. And of course, be ready for future regulations that at the moment maybe are they fit your vehicle specification, but they will not maybe fit in the future. We do that actually by considering this issue from the very beginning. I know it seems very simple as an idea, but it's often happens that you do not consider things like system updates or abrupt changes in your system at the beginning. And by doing something that is modular enough, you're able to really adapt in time. And again, this is always done in relationship with the client. So the client is always involved in every decision. And the idea of this puzzle is that, so you're able to every time change what you need and adapt. And in this way, you can deliver a good quality software. But you're going to say only 3 challenges. This is very general. Of course, it's not only 3 challenges. There are many, many challenges. We believe that these 3 challenges, of course, are generic and fundamental for any kind of robotic application. But then you go in deep. There are many challenges that arise for the specific application. That can be, for example, minimizing field testing, energy constraints, data management, and so on. But this will really focus on one of the particular fields that you are talking about. So I leave you with a question. So what are your challenges? So we really would like to have a talk if someone is curious about all of this, or has some challenges from the development point of view, the manufacturer point of view. So you can find us here at Hall 32 stand B8, and we will be happy to answer and have a chat. Thank you.
Thank you, Carmelo. Okay, we dig it deep into specific aspects of robotics in this case, which is the software. Now we go back to a higher level of view, but with a very, very specific task for machines to do, which is driving and guiding through different agricultural environments. Marco Bertogni, professor at University of Modern Bologna and founder of Hypert, will talk about that aspect of robotics and giving us also an example how to do that. And I take this hook because the product he's talking about is also in a live demonstration outdoor, so in the EIMA real area. So at 10 o'clock in the morning and 2 o'clock in the afternoon, you can see those machines running in the vineyard outside. Thank you, Marco.
Thank you, Alessio. Thank you, everyone. So the video is just to show one of these products that we have been doing. Two of them got an award here at EIMA. It's not a promotional talk about this stuff. It's just an excuse to try and entertain you a little bit about what are the big problems out there. So I've tried to build upon also what Matteo and Carmelo presented you before, okay? And also explaining a little bit what is our experience on try to do products, okay? So I'm a professor. I was lucky enough to become full professor pretty early in my life. With Carmelo, we spent the same time at the Scuola Sant'Anna in Pisa. I got my career in Modena. Everything was fine, okay? We were discussing just before standing in this stage that both of us got bored about the academic activities. Academic job is the best job you can have, okay? But it misses something, which is an impact on real stuff, okay? On useful stuff, okay? We have a lot of European projects. We have a lot of demo, prototype, and so on, but we never end up influencing practical stuff, okay? At least in Italy, okay? In Italy and also in Europe, okay? While in US, China, and so on, you have many, many examples of fruitful collaboration between academics work that become product, okay? So I started to understand what was the reason about it, okay? What was the reason behind it? And I also created a startup, a spin-off. We have our stand just here downstairs called Hypert, if you wish to visit us. And the reason is that doing a professor and doing an entrepreneur are two completely different jobs. Very, very different one from the other ones, okay? We had early prototypes of many things that now we are trying to sell, but between the prototype and the product, at least 3 years elapsed, okay? And we are not a few guys, okay? I'm leading quite a big lab. It's about 60, 70 people in the lab, plus 30 people in the company, okay? So it's quite a big, let's say, work power, but it's a mess to do a product, okay? To transform what we had in initial research into actual product that we can showcase at EIMA, not as a demo, but as a product. It's a lot of work, okay? So this is an example. This is I've been approached by this company, is also exposing here, and they wish to have something that was able to do lawn mowing, so cutting grasses, okay, in environment which are not the typical environment where the GPS is in full view, okay? Doing a GPS guide is nothing so difficult, okay? Something that a few guys can pretty do conveniently. The problem is when you don't have a GPS, when you can have obstacles, when you need to detect what is an obstacle and what is not. Try to do that, not filling with 1,000 lidars and cameras and 8 server on your vehicle, okay? Try to have the cost cutting down. Try to do the testing, the safety directive, the machine directive, the over-the-air update, the operating system. It's so complex to do even autonomous lawn mowing beyond the prototype that it takes a lot of work. Where is the good news? We have many nice companies, lab, academic groups AItronic, what Matteo said, they're amazing what they did, okay? The message should try to involve them. Let's reach them, okay? Let's try to reach them and help them doing together a real product, okay? To have an impact and not remaining just with one single prototype, okay? Italy is a very, very wealthy ecosystem. I still don't understand how we manage achieving these publication rates in Italy despite the zero funding that we obtain from ministry and a little bit from the European Union. But yeah, it takes some investment on the company to transfer what is a demo to a real product. What's that about? So this is a system that we created. The sensory part is easy. We try to cut the cost as much as possible, take the simplest sensor ever, and try to build everything on software to relieve the burden, the cost, okay, on the sensory part and on the computing part, and do something that is manageable. Today you can find, I'm sure that every one of you is familiar with those cleaning robots, autonomous cleaning robots, or autonomous lawn mower that cost less than a K, less than 1,000 euros, okay? So we cannot do something alternative that costs 20,000, okay? So you need to design something that is robust enough and that is amenable to work even in rough condition. It's safe enough to be sold in volume and so on, okay? This part cannot be done by an academic lab or a company, but should be done also with the bigger company that then has the scale to deploy it. You have the safety part, okay? So how do you achieve the machine directive, let's say, requirements in a convenient way without spending 5K on a sick LiDAR for safety, okay? That would cost more than the machine itself. How to allow an update of the software running on the machine when you are remotely without needing physical access to the vehicle itself, okay? That's another point which I invite you to consider. Virtual prototyping, I saw also in the previous talk, most of this is done first in simulation, and then you try to apply it in realities, how to reduce the sim to real gap, deploying real stuff that then you do not need to redesign everything when moving from a unit simulator or an Unreal simulator or a gazebo simulator, whatever, to the practical stuff, okay? And creating a digital twin of your green farm, of your logistic application, of your manufacturing building, and so on. This is also something that we are trying to do. The world is going to change a lot thanks to this system on chip, this embedded AI that we will be able to put in your vehicles, in the machinery that you are experiencing in these days, in this big trade show, okay? There are many, many things that we can do. Even with all the other companies like Hypert, we are not even competitor because the market out there is so big that there is everything for everyone, okay? It's just a matter of convincing the big farm here, the big companies here, the big machine builder here, that it's time to invest on software, to invest on planning, to invest on reliability, on safety, on this part that unfortunately typically have just very, very small offices of 2 or 3 people out there, okay? We're trying to make an impact here. The academic ecosystem is healthy, is wealth, okay, but it needs the support of this kind of companies. I'm not sure whether I touched what you were expecting for, but yeah, I tried
Absolutely.
to
Absolutely.
Thank
No,
you
that's a nice message and gives me some thoughts for a following question for you, but I asked that later on.
Later on.
Yeah. We're gonna touch the last point of that because we talked about developing, designing, programming, and so on, but then the machines have to be validated.
That's right. Okay.
Raffaele Giaffreda, Fondazione Bruno Kressler, please talk
Thank
about Agri-Food TEF.
Thank you. So we heard already a number of challenges that people have in producing applications and products that actually make it in the fields. So what do? We are in a position to help them in a way that is indeed for them useful. Okay, so Agri-food tech. I'm a researcher and innovation scientist at Fondazione Bruno Kessler from Trento, and I coordinate this project, which is a 60 million euros project, 5 years, that started 2 years ago, and is meant to build, you see there, the European network of testing and experimental facilities for robot and AI applications in the agri-food domain. So what are facilities? These are test fields that companies can come to us and use in order to test and validate their solution directly in real conditions. So not only real fields, but also digital representations like we have seen in the previous presentations, so that you can minimize the time you go in the fields, you can minimize the manpower that you need to produce something that is robust and can withstand the constraints that you find when you go to market, when you go to the fields. So the objectives for the projects are really to provide support for technology assessment, for compliance assessment. We have a legal regulation context in which that is changing very rapidly with the AI Act, new machine regulations, Data Act, Data Governance Act. There's a lot that is happening at European level that will have implications on what needs to be done from the compliance perspective before products can go to market. And then, of course, we touch on the business side. But just digging a little bit deeper, in the technology side, we have competencies as AI experts. So not only we validate the solutions from the technology point of view, but also from the robustness of the AI algorithms that are used. Not only physical services, we said, but also digital services. Not only in the domain of technologies, but also on the agronomic science side. We collaborate with agronomic science departments. In our partners, we have University of Milan was mentioned before at Italian level, but we got collaborations with Wageningen, Fondazione Edmund Mack in Italy. These are all companies that make a business out of research in the agronomic sciences world. We also have an opportunity to, as I was mentioning, accelerate the path to market through compliance checks. So you want to build a product, you want to go to market, you need to fulfill some regulations that are in the domain in which you are working. And therefore, this is where we help companies to do conformity assessment. And then, of course, we have think about the project. Right? The size is big. We have 60 million projects. We have 5 years duration and around 40 partners throughout Europe that are ready to support you with their competencies. So, and through that, we have a wide ecosystem of potential business opportunities that will become an opportunity for partners that test their solutions directly with us. So the target for us is mostly the companies that cannot afford to have too much resources to validate their products. These are the SMEs, the startup that they might have their own resources for quickly doing a test. But then what we do is we help them enlarge their own resources with additional facilities, as we said. So we see some pictures there of things that I've been playing with digital twins, with companies that do yield estimation, companies that do navigation in the fields, and so on. So in terms of types of services, what we do is can be categorized in 3 different domains. The robotics domain, where we help companies to better achieve autonomy. We help them achieve a better precision in the positioning as well as in the perception. Actually, Matteo is presenting some of their competencies. They are partner in our project, and this is the type of support that they help us with. Safety, a lot of autonomy means that you need to comply from a regulations point of view to having devices that are safe to use in the fields. And then the AI assessment part. There's a lot of algorithms that are behind those machines, as well as behind the software that does yield estimation, that does fruit picking, that does precision spraying, and so on, you name it. So you want to make sure that that AI is reliable. You want to make sure that AI can indeed run in isolation from the network as well, because this is part of the environment that you find in the fields. You cannot take for granted the fact that there is a 5G connectivity all the time. So you must be able to isolate your software and make sure that it works in isolation from the network. And then, of course, data. Data matters. There's a lot of data that we can collect through those experimentations, and we want to make sure that this can be reused. So experimental testing can produce a lot more data that can be processed afterwards and can be reused in different contexts by different companies. Oops. So just I wanted to close here with a success story, just to give an example of what we do. This is a success story that I've been working with since the start of the project. There was this company, which was a small startup, that they produced this software for apple counting and yield estimation. So what they do is take pictures and, videos, as a matter of fact, with cameras that are installed on the tractors. And what they do is, as the tractor goes, they process this data, and they need to do it in a way that doesn't lag behind the speed of the tractor. So they must do it live, and they need the things that have to be efficient from a computational computing footprint point of view, as well as from a memory usage point of view, and so on. So they came to us. We helped them understand where the bottlenecks were in their grouped containers, and we helped them achieve better results, more robust results that could indeed help their solution cope with the highest speeds of the tractor as it goes in the fields. And then one was the part of business. At some point they were wondering whether their solution could be of use for any of the machinery companies that we see many represented here. So I went to Alessio and asked him whether they had some of these companies that they could tell us about. And one of them actually indeed was interested in these type of solutions. They were all up for digitizing a little bit what their machinery does. And it was funny that I went to another event in Trentino. I was giving my speech, and next to me I don't see it very well here, but there was a poster in which this company had exactly the type of pictures that I had seen from geoinference. And then, of course, what they had done was, after I put them in touch, the Revo, which is this company that produces machinery for picking apples, they liked the solution that they saw from geoinference. They bought it, and that was just after they sold their first machine in Canada. So this is just to show a little bit how the full, let's say, ecosystem that we've got access to through our partners, as well as the competencies that we have, can indeed make a difference for small companies that couldn't have potentially afforded such a path of development that easily. So how to engage? We have a catalog of services online that is going to be more and more filled up with services. You can go directly to the website and see what is there available. What we do is we provide services. So services are delivered at a cost. The cost can be fully discounted if you are a small, medium enterprise or if you are a startup. How? Using the state aid instrument. That is something that is, come back and talk to me for details later on, but these are services that you can use eventually for free. And that's it. Thank you for your attention.
Thank you, Raffaele. I kindly ask all of the speakers to join us on the stage for a short question round. We are just on time, so no hurry. But I have a few questions. Maybe we can have some more time also for a couple of questions from the audience. First is for Matteo. You can drink, no worries. I'm gonna ask you a very short question, and I ask you to be short in your answers. What about performances? When it is about using your perception system and do some action. What's the difference of the performance now against the same operation made by a human, for example?
There is clearly still a lack of performance with respect to human picker, for instance, in machines. But this really depends on the kind of culture and the setup. There are cultures where clearly humans are faster, but they are limited in time. They cannot do 24-hour, 7 days a week. So right now, if we consider that a machine can work 24/7, we are still, depending on the culture, like 3 times lower, 5 times lower. But I mean, we are at the beginning of this. So I think that in 5 years, 10 years, we will see more and more these machines catching up in performances and in quality of the activity. But it has to be taken into account that we are witnessing a change in labor in the agricultural field. So it's not I don't think it's a problem of it will be fast or not enough to keep up with a human labor. The problem is that we don't have human labor at all. So it doesn't really matter whether it's slower or faster. It exists and it's a viable solution.
Thank you, and that's true. One of the aim of robotics actually try to fix the lack of labor we have, but definitely there are a lot of people asking, but what's the performance of this system? That's why of my question. Carmelo, when it comes to take control and maintain the software after deployment and after the distribution of products on the market, how is it? How does it work? How you can keep the control of that?
So this is a point that is crucial. Also, Marco did some talk about that. What we do is actually having an entire system that is able to is based on containers. So you're able to have some versions of your code, version control, and we apply software updates on the air, so basically through Wi-Fi or by physical access to the machine, depending of the product. Because one of the main challenges is also that sometimes some producers do not want, for example, to have a Wi-Fi connection to the vehicle. So you have to create a smart way to actually interact with the other machine when you do not have access. Many infrastructures, sometimes infrastructure do not exist at all, so it's not really easy to be able to control the system. So what we do is actually some standard asynchronous way of contacting our servers and getting updates. But what I believe is important is that we are able to separate the various level of applications like localization, navigation, and guidance in different separated containers, and only change some of these portions. And this also easy up the download and the deploy of the software.
Yes, definitely. Let's say compartmenting the container is one important thing, and this drives me to the question I had in mind for Marco, because you talked about safety. You mentioned machinery directive, which is going machinery regulation, including AI and whatsoever. But definitely, there's another aspect which is functional safety. How important is it to take into account it at earliest stage of the project, which is something that somebody still forget to do?
Very, very good question. So both me and Carmelo come from this lab from Pisa called the Real-Time System Lab. Real-time systems are very, very involved about safety, okay? So how do you ensure that everything that you do does not just have the right solution, but the right solution in time? With anything worse that can happen, it still will do that, okay? So real-time systems and safety system, machine directive, ISO 26262 in the automotive and so on, it's of paramount importance, is not at all well covered in academic studies. Okay, there are very, very few studies that cover this discipline. there is a shortage, a significant shortage about people that knows about that, okay, and knows what to do about it, okay, ending up overspending in safety stuff that is not produced in Italy. There is just one company which I know that develops safety relevant radars in Italy, or everything else is outside Italy, okay? And if you do your application and then you realize it needs to be safety certified, you either redo it from scratch or you pay twice what you paid for the development, okay? So it needs to be taken into account from scratch at the beginning, okay? That said, our typical approach is to decouple the navigation and like AI part with the safety subsystems, okay? So try to make the safety subsystem as simple as possible, okay? Very, very simple sensor, very, very simple actuator, or just get out the energy on your system and stop. And the complexity you leave in the unsafe part of it, because if you try to certify the complex autonomous driving part, good luck with it, okay? You may mention Elon Musk. Elon Musk is doing Teslas on Linux with no safety stuff around, okay? I'm not sure how this will last or will able to enter the European market level 4. Not even NHTSA and NHTSA directives in US. He's gonna face some problem, okay? Beautiful idea, beautiful demo, beautiful prototype, just based on vision. It's amazing what they did, but safety is another thing, okay? I don't have the solution of it, okay? I don't know how to make safety relevant, something based on AI that can be also manageable, updatable, over the air, and so on. That's the biggest question ever, okay? It's gonna be answered in the years to come. Also will have some relevant impact as long as we will improve this generative, this performance, the AI performance that we can get, precision and so on, but it's a totally open question there, okay? So for now, think on it about the beginning, since the beginning, and try to decouple the safety part, making it as small as possible.
Yeah, definitely situation between US and Europe is much different. We're going to facing Artificial Intelligence Act, product liability, and Cyber Resilience Act and whatsoever. So maybe even Tesla is going to face some problems with the full autonomy, but definitely something we also our manufacturer has to take into account in the future. How to validate AI-based system, nobody knows, but definitely it could happen that the European Commission will ask to do that to our industry. But in the end, we still have to validate it. Raffaele told about the services and the activities of agri-food theft. You gave already one example of a company using your services, but you have a couple of more success stories of companies in agriculture using your services to validate their applications.
Yes, that's right. So, well, there are some other companies that are using our services. There's a Spanish company, for example, called Microfy Systems. They work pretty much on computer vision stuff to certify the quality of honey. So they produce microscopes that they can use trained algorithms to recognize specific type of threats to biology threats or bugs that can be found in honey. And what they did was to get some help in validation of their AI software for recognizing specific problems that the honey can have. And the way they're using this, let's say, network of facilities across Europe is by helping or getting some help in training their vision algorithms as well with bugs that can be found in different locations in Europe. And this is something that as a small companies, they wouldn't necessarily have the opportunity to do. So there are these type of services that are being deployed. We have also other discussions with companies that are, for example, working with bee hives. Bee hives as sustainability sensors in the fields, and there as well, there's a lot of data that is collected in the fields for assessing the number of flights for bees, the activities in the hive, and there's a lot of manipulation that has to be done from that data to relate the quality of life, let's call it that way, of bees to indeed the sustainable environment they're living in. So also on that point, there is a strong emphasis on sustainability of agricultural productions, and there's a lot of need for solutions that can indeed go and support those farmers that are moving in that direction. So, yeah.
Thank you, Raffaele. We started 5 minutes late, so I believe we can take 5 more minutes for a couple of questions for the audience, if there is any. Any question from you? Something that has not been covered by our experts? Looks not to be the case, so I'd like to thank all of you for coming, giving your hints and your ideas. I believe we covered a lot of different topics, different aspects of robotics and perception, AI in agriculture. A lot more is to be covered, but definitely I live for with a word that came up in my mind again and again today, which is networking. You mentioned that we need to stay in touch with each other, networking, try to do the things together, because this is the only way we can compete maybe with the rest of the world. Thank you for being here. I recall tomorrow another schedule of interesting events in this area, starting at 10 o'clock tomorrow morning. Thank you again, and have a great EIMA.